past chair of Eastern Branch. I'm standing in for John Kelly, our current branch chair, who's unfortunately extends his apologies as he's unable to be present today. Please, can you help us all by ensuring your cameras are turned off and your microphones muted? That enables us to make the most of the bandwidth. It's my pleasure this afternoon, to welcome Julian Welbank, who will be talking to us about strategic water resources within England. A subject I think is of great interest to everyone, bearing in mind we all use water in some way, and I can see that's supported by a very good attendance today. I'm particularly interested, obviously, after many years within the water industry, and I'm sure there are colleagues here both from within the water industry and for those where maybe this will be something new for them. Please use the chat function for any questions, and we will pick those up at the end of the presentation. So without saying any more, I'd like to welcome Julian. Over to you, Julian.
Okay, thank you, David, and good afternoon, everybody. Hopefully everybody can hear me and see the slides on their screens, which I'm sharing from my monitor. So this is a really exciting and interesting time in the development of water resources across England. There's quite a lot of activity at the moment, and hopefully I can convey why that's happening. So it's a pleasure to be invited by the Pipeline Industries Guild to talk about that. What I would like to do is to kind of give you a bit of background as to why the program's come about, what momentum has been built up on the development of water resources across England, some of the scale of the challenge that faces the country over the next 25 to 50 years, some of the options that are under consideration, a little bit about the programme, the kind of near-term programme. That photograph on the slide is a Rodford Reservoir in Devon, showing the embankment in the middle and the Dwarf Tower on the right-hand side. So why has this programme come about? Those of you with a certain age or certain good long memories will remember there were droughts in 1975 and 76, particularly dry winters in 1975, and similar thing in 1995. But in recent times, the most significant drought event was in the period 2010 to 2012. In that period, there was quite a long period of time in the spring and autumn with below average rainfall. The analysis showed that that period was one of the most significant droughts of that duration in the past 100 years. It affected the country in different ways in different parts of the country, but there were low reservoir levels at times in the north of England. There were hose pipe pans in some areas. There were quite severe impacts on agriculture, particularly in the east, and on the environment. The diagram on the right-hand side shows the average rainfall in the period April 2010 to March 2012, compared with the long-term average. And the brown squares on that diagram signify rainfall that was significantly below average, 65 to 75% below long-term average over that period. In true kind of British fashion, it ended with a deluge in April to July 2012 with exceptionally high rainfall. But it was quite a wake-up call, and the industry and government started to think about what do we need to do. In that period, there'd been quite a lull in the development of new resources because for many years companies had relied on demand management rather than developing new resources. But it was recognised that that might not be a viable way forward in the future. So there was quite a lot of regulatory and political desire to have a think about that and to raise the bar, greater level of ambition. There was a report published in 2016, sponsored by Water UK, looking at long-term water resource planning, that highlighted that there was a gap, a challenge over the next 20, 30 years to make sure that we had enough water to supply customers. That was followed up in 2018 by the National Infrastructure Commission, who prepared a report called Preparing for a Dry Future, all part of their remit to look at the status of infrastructure across the country. And they highlighted as well that some action was needed to make sure that there were resilient supplies for the future. It's all part of their remit to make sure that infrastructure is being considered appropriately by government agencies. And they particularly highlighted that there needed to be an increase in the level of resilience provided by water infrastructure. They looked at it from a kind of macroeconomic point of view and looked at what would be the cost of responding to a severe shortage of water compared with the cost of planning to avoid that situation. And as many of you will know, it's logically much cheaper to plan to avoid a situation rather than have to react to one in a short notice. And their analysis showed that it was cost beneficial to improve the level of resilience. That was followed, those two reports were followed by a further report published by the Environment Agency in 2020 called the National Framework for Water Resources. So this was a big departure. Prior to this, over the past 20, 30 years, water resources has been very much prepared on a water company basis, using guidelines issued by the Environment Agency, but without a national framework. The national framework set out some policy objectives that companies and stakeholders should work to. One was to improve the level of drought resilience, as I mentioned, from a current situation where the return period for restrictions, this is rota cuts, actual restrictions in available supply, currently sits at around 1 in 200 years, but that is an annual probability. But if you look over somebody's life, say 80 years, an annual probability of 1 in 200 translates in a 33% chance that you will have one of those events during your lifetime, which is relatively high. And as I say, the NIC came up with a basis for establishing that should to be improved to a return period of 1 in 500. The national framework also seeks to set very high ambition on reducing demand, both consumption and leakage. So the aim is to try and reduce customers' consumption by about 1/3 and to reduce leakage by 50% from 2020 kind of starting point by 2050. As well as that, there was a desire to increase sustainable and cost-effective supplies. There was a recognition that you had to transfer water to where it's needed, and also to include other sectors, not just customers served by water companies. And a desire to be much more ambitious about long-term environmental needs. Recent past has been characterised by environmental improvements, but very much on a kind of 5-year by 5-year basis, which is not at all helpful if you're planning on a 25-year or 30-year or 40-year horizon. So there was an aim to be much more ambitious about thinking about the long-term environmental needs and to reflect the impact of climate change on how much water is required in the environment. So the national framework confirmed that there was a national deficit by 2050 of the order of 3,400 million litres per day, made up between, broken down between making supplies more resilient, the need to serve a growing population, the need to replace unsustainable abstractions, and to mitigate the impact of climate change on the yield of existing sources. That, if you put it in context, average total output across the country is around about 14,000 megalitres per day. So this was saying you need another 3,400 megalitres. The national framework also reiterated a thought that had come about through the previous reports, was that these issues couldn't be tackled by company. A bigger geography was required, and therefore it should be planned on a much more regional basis. So the national framework required regional groups to be set up, which has happened, and for the regional groups to consider their own needs and also how they could service or help with the challenge for their neighbouring regions. As I mentioned at the beginning, it's quite an interesting phase now. We've been 2 years into this process since the national framework was published, and the first regional plans have been issued for public consultation. That actually commenced last week, so this talk today is really good timing. There was a national launch last Monday, and some of the regional groups launched their own plans last week, and that's carrying on this week. These are the 5 regional areas. Water resources southeast, water resources east, where a lot of you are, I think. Water resources north, water resources west, and water resources in the West Country, which is where I'm sitting. You'll notice Wales is left off this diagram, and Wales has its own process. Obviously, there's a much more direct relationship between the water company and the government in Wales, and it has its own policies, but there are interactions between Wales and water resources west. The regional plans need to reconcile with each other. It wouldn't be, it was obviously totally illogical that different regions assumed they would be using the same water, and an export from one region has to reconcile with an import into another region in order to develop a national coherent picture. The 5 regional groups, as I mentioned, have started consulting on their plans commencing on the 17th of April, which is last Monday. So just to go back to the scale of the challenge, the national framework assessed this and came up with a prediction that there was a need for 3,400 megalitres a day of additional water, split according to this pie chart between the need to improve drought resilience to a more onerous situation, the need to mitigate for the impacts of climate change on the yields of existing sources, the need for environmental protection of sensitive rivers, particularly chalk streams, population growth, and then other requirements as well. That 3,400 was very, very much in line with the assessment that the National Infrastructure Commission made of a need of around about 4,000 megalitres per day. The national framework position has now been updated by each regional group looking at their own requirements, and the total challenge has probably gone up by about 1,000 megalitres a day, which just reinforces the need to think very hard about the long-term challenges for water resources across the country. But I would also highlight that there are very large regional variations. About 50% of the total quantum of additional resource required is in the southeast of England. Perhaps not surprising. That is obviously the area with a large population, so the population change there is a large part of the total, but also it's the area with some of the most sensitive environmental needs, chalk streams in particular, where there is a desire to protect those much more in the future. So the southeast needs a significant amount of the total, and then climate change also affects different regions in different ways. So there's quite a variation on those pie charts, as you'll see. As I mentioned, that environmental needs are not evenly distributed across the country. One of the bigger challenges is to protect chalk streams or rivers that are fed by chalk aquifers, and the national framework envisages quite a major reduction in abstraction from chalk. But chalk is one of the predominant sources of water in the southeast and into East Anglia and across into the Wessex area, which is where I am. So moving on to having a discussion about the options to meet future needs. The aim is to adopt a twin track approach, both looking at demand and looking at resources. The overall principle of water resource planning is to make sure you've always got sufficient supply to meet predicted demand. So the graph on the right-hand side illustrates that. The overall, the blue line, the solid blue line is demand plus headroom, which is a contingency above predicted demand, and the red line is water available for use. The aim is to make sure that the red line is higher than the blue line in every single year of the planning period, from now until whenever you choose to design your schemes for. But there are pressures on these predictions. The red line is could potentially subject to reductions due to the impact of climate change on the yield of existing sources and the needs of the environment if we want to protect the ecology of particular locations. The blue line is subject to increases due to population growth, but also potentially reductions due to reduced leakage and reduced consumption. So the idea is always to manage these two lines in twin tracks, to always be trying to reduce demand, manage demand, and to create additional resources such that they can be deployed when required to make sure that red line could be increased if needed and the water can be transferred across the country. So as far as demand reduction is concerned, the industry has committed to a 50% leakage reduction by 2050. in line with the government policy. That would provide about 600 megalitres a day of additional water. There is also a desire to reduce consumption. That would be through a mixture of more metering, which has a significant impact on customers' usage, through water efficient devices in houses, water efficient housing, and government interventions to make sure that we buy water efficient appliances. This is a big ask. During COVID, there's been quite a bit of a change in consumption. Obviously, people's use at home has gone up and people's use in the office has gone down. It's hard to tell exactly how that will pan out in future, but it doesn't look as though it would be a significant kind of net reduction. So to reduce from where we are now is very ambitious. The total of those two is about 2,000 megalitres a day out of, so roughly half the total national need. But that reduction is not evenly distributed across the country. In fact, it's largely produces water in the areas that we don't currently really need it. But if we were to meet a national situation, that helps, but there would need to be a way to move that reduction across the country. The conclusion is that non-delivery of these ambitious demand reductions is quite a significant risk to worsening supply deficits and to security supply. So it's very hard to rely on them. It's right to set ambitious targets, but it's hard. It's also probably not appropriate to rely on them delivering. If we rely on them and don't leave ourselves enough time to react, then that would be a bad situation. But even if they all materialise, that only delivers half of the future challenge. So there would need to be supply side schemes to improve available water supply to resolve the future deficits. Some of the supply side options that are being considered, shown on this slide, particularly favoured are additional reservoirs where we can store water that's available in the winter for use in the summer. That has quite a few merits in terms of its ability to respond to droughts, ability to manage climate change issues. Effluent reuse is very much being considered. All across the country, effluent is discharged back to rivers in a relatively unplanned way. That's been going on for decades. But there are locations where effluent is discharged to the sea. It's already gone through a fair amount of treatment, but with additional treatment, that effluent can be recovered and reused as a water resource. And then there can be abstraction from rivers where there is excess winter flows, or where flows in the rivers are supported by releases from upstream. It seems clear that additional groundwater abstraction is going to be very challenging. And then the kind of long stop option is to think about desalination, which obviously in other parts of the world, which are much drier than England, is used as a water resource. To kickstart this whole process, at the price review for the last AMP period, Ofwat allocated funding for development of a programme of new solutions to partly meet this challenge. The diagram on the right-hand side shows some of these proposed projects. They are predominantly, as you will see, projects designed to try and transfer water from west to east or from north to south, focused on trying to get additional resources into southeast of England, but also by providing additional resources in the regions that would enable each region to improve its resilience as well. So the 17 schemes started as a portfolio of projects, and the work started on those in 2020. There have been some new schemes added to the portfolio, an additional reservoir in East Anglia, the proposal to look at a quarry in the Mendips, and a proposal to look at raising existing dams in the Derwent Valley in Derbyshire. These projects are following what's called a gated process, where each project has to submit a report at a specified time to get through the gate to the next stage, and then will be given funding to carry on to the next stage. I mentioned earlier that river abstraction is feasible, but it's particularly feasible in the winter. Many rivers have high flows in the winter, and they can be used. Those flows can be used to store a reservoir, but you have to have somewhere to store it. The focus on environmental sustainability reductions is all about the low flows, but on this graph you can see there's like a 10-fold increase in flows in the winter that's available to be stored, and a lot of our learning on all kinds of different events shows that if you can have a store, that mitigates against a lot of supply chain kind of problems. So the portfolio includes a number of new reservoirs. One of those is down in Portsmouth Waters area at Havant Sicket, proposal to build a new reservoir to store spring flows that are available in the winter. The last reservoirs in this country that were built were completed in the early 1980s. So this is really quite a departure now, and it's generated quite a momentum to try and consider additional reservoirs. So there's the one down in Portsmouth I mentioned. The top diagram is an artist's illustration of a bunded reservoir in the Fens that would be filled with flows from rivers, and the diagram at the bottom is the southeast strategic reservoir option, which would be filled by transferring flows from the River Severn and would be able to release flows into the Thames. These are large projects, take many years to get off the ground, but if we're to avoid a crisis in 20 years' time, so the proposal is to move on the most optimum set of solutions. To go along with the reservoirs, there needs to be transfers across the country. This diagram illustrates some of the transfers that are being considered. They're both raw and treated water transfers, both pipelines and using rivers and canals, with a variation in kind of size. Some of these projects have been considered in the past, but many of them are new projects as well. Emerging from the regional planning, some of the supply infrastructure proposals have been issued out for consultation, and that slide there kind of summarizes some of the proposals, which perhaps I'll kind of leave people to look at afterwards. There is also desire in the guidelines to move away from planning based on least cost. That's been the general philosophy in the past, to consider the cost of projects and always choose the least cost option to meeting a challenge. But in future, there is a desire to look at the additional benefits that these projects can provide, and to make sure that we're factoring in the intangible, in some cases, additional benefits of solutions. Just to kind of wrap up, really, a little bit about programme. The environmental aspirations are very much linked with the government's 25-year environment plan. The regional plans and the water resource management plans are required to consider a minimum of 25 years, but many of them are considering 40 years or even longer. The policy ask to improve resilience against droughts is required by the late 2030s. And we have to factor in the length of consenting and implementation for the projects that I've mentioned. This is a diagram showing the gated process with the gates and the timelines and how they align with the water resource management plan. And this is quite a busy diagram produced by Ofwat, explaining how the regional water resources plan and the company water resource plans and the gated process align, and how they align with the business plan process. So there's a hierarchy of plans and documentation, starting with the national framework, then the regional plans, then the company plans, and the development of particular solutions running in parallel. So just to summarize before we have questions, I've tried to kind of cover some of the background, how this has come about from government and from regulators, the scale of the future long-term water resource challenge, some of the options under consideration, the twin track approach, demand management, supply options, new reservoirs, and some of the near term, the kind of immediate program drivers and some of the longer term drivers. So I hope that was interesting, and I'm more than happy to answer questions, which I guess would be managed by David.
Thank you very much, Julian. That's a truly excellent presentation. Very interesting indeed. Yes, we do have a number of questions. I'll kick off with take chairman's prerogative here, actually. Just before you mentioned about water recycling, I did actually ask you, in order to meet demand, can more use be made of water recycling? This has been implemented in one or two occasions in the past. Feeling was that there was perhaps a lot of, should we say, customer resistance, or there might be customer resistance, the idea of the potable water side getting mixed up with the water recycling side, or the sewage treatment side. Do you think that has now moved on and people will be far more receptive, in terms of a real water shortage?
Yes, I think so. I think if you take time to explain some of these things to customers, and a lot of this is and stakeholders, it does take time and it does take a lot of effort to make sure people understand. But I think recycling in general has become much more accepted and is standard behaviour. In fact, it's the norm, isn't it? If you don't recycle, you're frowned on. So I think if we can use the word recycling rather than reuse, and we can make sure we've stepped through all of the issues, that has a real potential. It will always, the current thought process is that it's always indirect reuse. So it's mostly an approach where effluent would be further treated at the sewage treatment works and then transferred to a river, so that there was an environmental buffer in the river, or to a reservoir, so there was an environmental buffer there, then re-abstracted and retreated before it was supplied to customers. The alternative of direct reuse is probably many decades away, and it's clear that we ought to look at indirect in the first, which happens on an unplanned way anyway.
Yes, indeed. I mean, I can think of places in the east where, and of course, Thames is always, the River Thames is always the oft-quoted one, isn't it? Of Oxford's water being, Oxford sewage being effluent being drunk many times before it actually finally reaches the sea at Southend. Excellent, thanks for that. Now, hold on, I'm looking at some other questions here. I've lost one of them. Where are we? Here we are. That's right, from Alicia, asking about, sorry, lost it. Yeah. Is universal metering being considered at all?
Well, kind of yes, in a way. The much greater part of the country is now being classed as water stressed, which provides the water companies in those areas to have universal metering or compulsory metering. But there is quite a reluctance or nervousness about adopting the word, using the word compulsory. It has to be said that many companies already have quite high meter penetrations anyway, 60–70%, or in Southern Water's case, nearly 100% in any case. So I think metering will be part of the solution, and it will get to very high levels all across the country. But the preference is to try to do that without compulsion, by making it attractive to customers to move on to meters. Yes,
because I can certainly remember from my time at Anglian, and we're probably talking about more than 20 years ago now, when the company brought in a universal metering policy at that stage, and then got quite a substantial customer resistance and had to change that policy fairly quickly, actually. So that's a very good point. Another question from David Bullock. Trying to remember the whole. Yeah. Thank you, Julian. To what extent do you think that implementation of the supply side transfer options is compatible with the current regional boundaries and regulatory structure of the UK industry? That's interesting.
Yeah, this is actually a challenge that's being addressed at the moment. I should have mentioned that the portfolio of supply side projects is being overseen by an alliance of regulators called RAPID. That's an alliance between Ofwat, EA and DWI to put all of the regulators in one group to make sure that they're aligned. And one of their things they're thinking about hard is how to organise the funding and allocation of kind of responsibilities for supply side schemes that are potentially meeting the demand in one region with using a source in another region. That's what some of the schemes involve, but the particular structure you need to achieve that hasn't been fully sorted out. I think it can be overcome. There's no reason why it can't be overcome. There are already examples of companies who have sources and treatment works outside their boundaries. So it has been done in the past. I'm sure it can be done in the future.
Yes. Because I can think of quite a few locations in the east where that's the case. Okay, thanks very much. Another question from Elizabeth Lang here. Have large-scale industrial water users, i.e. hydrogen plants, being considered for using recycled water rather than potable?
That, as I was talking about effluent reuse earlier on, obviously a clear possibility is to use effluent to supply industrial customers, and that is being looked at in across the country to a degree. Had some experience of working in Singapore, and that's certainly where they started with effluent reuse, of using water from their effluent sewage treatment works to supply industry. Hydrogen plants is a relatively new thing. I have to say, and I'm particularly au fait with how much water they would potentially need, but certainly using recycled water for non-potable uses is being considered.
Yeah, thanks. I'm thinking from what my involvement with hydrogen within the Guild at the moment, there are a number of areas being used, and one of the opportunities I think is for industrial use of hydrogen in limited number of plants, which might actually tie in with the recycling from particular sewage treatment works, which might well work. So that could well be a possibility. Moving on then, Grella McGrath has asked, to what extent have the regional plans considered benefit schemes for communities, regions from which it is proposed to export water resources?
Yeah, this is a very good question, actually, and quite a challenge to resolve. There's been a certain amount of customer research about whether customers are in favour of exporting water outside of their region. The general feedback from all of the customer research is that customers are more than prepared to kind of meet the common good if the needs in their own region have been satisfied first. It's not particularly favoured if it means a poorer level of service in one region in order to deliver a better level of service somewhere else. So that's a kind of customer view, but it's potential that there is a potential that these schemes could also deliver additional benefits in the donor region. But quantifying these benefits, I mentioned best value earlier on. Quantifying those benefits and making sure that that's considered in the round is quite challenging. Even if you could deliver a benefit in one region in order to achieve a need in another region, how do you square those off, and what are the trade-offs? So that is being considered, but to absolutely nail it is quite challenging. So there's further work going on that.
Okay, yep, thanks very much. Question from Trevor Walkinshaw. Any discussions with Scotland re water transfer options?
Not that I'm aware of, Trevor. I think the furthest that's still being considered is Kielder, is obviously an underutilised resource, and a bit of a lesson actually to some of the work that we're doing, where a resource was built up in Northumberland to meet a demand that didn't arise. So that's a lesson as well, to something to avoid. But having said that, some of the resource there, I think, is being looked at to be moved within West Country North area. I have to say I'm down in the southwest, so I'm not au fait with the proposal, but I haven't heard of any discussions about Scotland.
So is it probably right to say that generally within England there is a balance of water, it just happens to be in the wrong places?
Yeah, that is kind of true to a degree, David, but also a lot of the populations in the southeast of England, and some of the pressures of climate change hit on the east and the southeast more than they do other parts of the country. But it is true that a solution would be to move several hundred million, several tens of millions of people from the southeast up to the north, but that's obviously not going to happen.
Yeah. Quite interesting, actually, is a comment from Ewan Innes, letting us know that there are limited water resources in Scotland, south of the central belt. So it looks like that within, should we say, easy reach of England, there aren't necessarily any available resources anyway, or spare resources.
Okay,
that's good. Another question for myself, actually, when you mentioned the funding of these seven, well, I think you mentioned 17 projects, and then another 3 that were going through a process. Presumably, And there's the gated approach, which I sort of fully understand from my time in the water industry. Presumably, when projects go through that, then when the funding is accepted, then the funding will be will form part of a particular company's business plan, will it? When the latest periodic review comes up.
Yeah, that's correct. So the 460 million that's allocated to the original 17 projects is already factored into business plans, and customers are funding that spread across the projects and divvied up amongst groups of companies. So each project, most of them anyway, are multi-company projects with several companies contributing and their customers paying the proportion of the costs. Yeah. So that's already funded. If a project doesn't proceed through all the gates and stops at a particular gate, then the remaining funding is handed back to customers as part of a reconciliation at the next business plan.
Yeah, fine. And I just a comment from myself, actually. It's very interesting in the projects that are being looked at. You showed a slide with the Portsmouth Reservoir and also the southeast one. The southeast one is that the famous Abingdon Reservoir that from Thames that never actually went ahead.
Yes, that's correct. That is Abingdon Reservoir. It's been renamed because it doesn't serve Abingdon, obviously, but no. It is to very much for the southeast of England, for Thames Water and Affinity Water, and potentially for Southern Water as well. So that is a very large bunded raised reservoir to be filled with excess winter flows, and then to be drawn down to maintain river flows in the Thames and to be abstracted further downstream.
Okay, excellent, thanks. Well, that seems to be the end of the questions. Remains me, Julian, to thank you very much for a very interesting, very actually fascinating presentation on something which is very, very important to all of us. So thank you once again. Thank you for everyone that attended. I think we do have about sort of 5 or 10 minutes now. If anyone wants to stay on and have a general chat about water resources with Julian or anyone else, you can now unmute your mics and turn your videos on. But should we say that's the end of the formal proceedings, and Catherine, you can stop recording now, I think, please. So yes, thanks very much.